Hello, everyone. So, today is a lot of reading. Before we're going to start, I would like you to take out your phone, set a timer to 5 minutes, and please read and reread number 1 to number 3 on this section. So, 1, 2, and 3. So, please read these 3 sections. You may start to read anytime. Please pause it and go ahead to read. 2, 3. Okay, come back. Thank you for following direction to read because this is the first time we're going to talk about proof, which is actually the Lex Unit. But since we're talking about the transversal and the angles inside the transversal and the parallel lines, so I want to talk about the proof first and also get you ready to see what is a proof look like for the Lex Unit. That is the hardest unit and a lot of thinking, a lot of logical thinking, provide evidence. You will see many people complain that is the hardest unit. So the first theorem is corresponding angle theorem. And if you see the two lines are parallel, line L parallel to line M, and then the corresponding angle, which is angle A and angle B, and we talk about same position angle, they are always congruent. So in this case, we said if line L parallel to line M, angle A is congruent to angle B. Converse, it means to switch. So if angle A is congruent with angle B, that means that line L is parallel to line M. Number 2, alternative interior and exterior angle theorems. So if the two lines are parallel and then the alternative interior angle or exterior angle, they are also congruent. So this is just what we list on the reference paper. So over here, if the two lines are parallel, angle 1 is equal to angle 2, and also angle 3 is equal to angle 4, their exterior angle. And the converse of the alternative interior and exterior angle, that means if angle 1 congruent with angle 2 or angle 3 congruent with angle 4, they are alternative interior angle and congruent, and 3 and 4 they are alternative exterior angle congruent. In that case, the line P will be parallel to line Q. The last theorem would be consecutive or same sign interior or exterior angle theorem. The first one is saying that if line L parallel to line M and then angle 1 plus angle 2 is equal to 180 degree. Angle 1 and angle 2 are supplementary angle because they are same sine interior angle. Same as angle 3 plus angle 4 equal to 180 degree because they are same sine exterior angles. They are supplementary. So on the other hand, the converse is saying that if those two angles add up equal to 180, then the two lines are parallel. Please read if you didn't do it. Okay, now let's take a look at one of the example. This is actual proof. You want to see much more on Unit 4. Giving line L parallel to line R. What I usually do, I really have a pencil that you draw on it. Line P parallel to line R. So you see I put the parallel, the little arrow on line P and line R. Angle 1 congruent with angle 3. And we have to prove that line L parallel to line M. So the red one is what we have to prove. So step by step, we always begin with the given information. You just copy down the given line P parallel to line R because it's giving. And what's the reason that angle 2 is congruent with angle 3? Are they on the same side or different side? Right, different side. And they're exterior or interior? Exterior. So they are alternative exterior angles. They are, every time you hear the word alternate, they are congruent. So if two lines are parallel, the alternative exterior angles are congruent. You're going to write down on the reason. The next, angle 1 congruent with angle 3. What's the reason? Look up here. Given? Okay, they are given. Okay, number 4 would be angle 1 congruent with angle 2. What angle are they? Okay, many people will feel they are corresponding angle because they are the same position. Don't do that. Okay, look up to number 2 and 3. That's why we're writing proof that you're getting the information from the previously statement that you wrote and making conclusion. So for number 2 and 3, you can make conclusion. And for the number 1, you can make conclusion of from angle 2 congruent for angle 3. Now, combining 2 and 3. What is for the 4? Why angle 1 is congruent with angle 2? So looking at this and looking at this. Both of them have angle 3. So this will be a Liu theorem. Right? When two angles are congruent to the same angle 3 here, and then those two angles are congruent. That is transitive property. You're going to use this one more and more often in Unit 4. And now we can prove that the two lines L parallel to line M based on angle 1 and angle 2 are congruent. That is the one of the theorem we talk about. So let's go back to see which one it is. 1, 2, or 3. Okay, let's go back to the picture. And then you can always look up to see which one. Angle 1 congruent with angle 2. Okay, let me make it more clear. So angle 1 congruent with angle 2. Those two angles are congruent and making the line L parallel to line M. Which theorem it is? Looking back, 1, 2, 3. The first one is corresponding angle. The second one is alternating interior angle. The third one is alternating exterior angle. Which one do you think angle 1 and angle 2 is? They are having the same position, which is corresponding angles. Okay, so that means first theorem you see. So corresponding angles are congruent and then the two lines are parallel. That's it for today. Hey, if you have questions, please come see me. Get ready for Unit 4. It's all about proof. So have a wonderful day.